AP Calc, here we are. We are going to go through these two examples from definite integrals, number 23 and number 24. I had started, so this will be number 23. And here we have the integral of negative cosine of x dx from negative pi over 6 to pi. And we want to integrate this, and we want to integrate this with these bounds. This one you can see doesn't require any u substitution. So we've got cosine right here, and we can take the integral of cosine. But before we do that, some tricks here. So since you have this negative right out here, one thing we can do when you have a negative is to take it to the outside, and you can take any constants to the outside. So that negative can go to the outside of our integral, and we got negative. Same bounds here, negative pi over 6 on the bottom, up to pi of cosine x dx. And if you want to get rid of the negative completely, we can also do that. So to get rid of that negative sign completely so we don't have to worry about it later, we can take the negative away, take the opposite, and just change our bounds. So remember, one property of definite integrals is that if we change the upper and lower bounds, then it's going to give us the opposite. And so we're just going to rewrite the integral, same thing. This time going from pi to negative pi over 6. So basically it's going backwards. And still cosine of x dx. All right, well, cosine is a fundamental trig function. We can take the integral of that. You should know that the integral of cosine is just sine. So now we integrate, and we've got sine of x. And we are going to evaluate that. Our upper one is still going to be negative pi over 6. The lower one is going to be pi. Okay, so if you have a calculator, you can just plug those in. But I'm going to show you how to do it without a calculator. So you can, hopefully you know your unit circle. I am going to use my special triangle. So let me make it more special. So let's make our special triangle, our basically a 30, 60, 90 triangle, but we are using radians in calc. So instead of 30 degrees, this is going to be pi over 6. And instead of 60 degrees, this is pi over 3. And this is an equilateral triangle, or half an equilateral triangle, where this side is going to be 2, this side is going to be half of that, it's going to be 1, and by Pythagorean theorem, this is always going to be square root of 3. So there's our special triangle. And if we consider our bounds here, first off, we have to do the upper bound, negative pi over 6. Well, that's going to be down here. And sine is always going to be negative in the fourth quadrant. So what is sine of negative pi over 6? Well, we can go to this triangle. Sine is opposite over hypotenuse. So the opposite side would be 1, and the hypotenuse would be 2. So since we're down here, it's going to be negative. So that's going to give us sine of negative pi over 6 is going to be negative 1/2. And then sine of pi, where is pi? Well, pi is over here on the unit circle. Sine is the height of it, the y coordinate. So that's going to be 0. Sine of pi is 0. Okay, so we take sine of x and we plug in the upper bound, negative pi over 6, we get negative 1/2. We plug in the lower bound, pi, and we get 0. And we simplify that, and we get our answer of negative 1/2. So that is our final answer. All right, let me do the next problem. The next problem is 24. So I'll just put that up there. And 24, kind of similar. Again, it's a basic trig function, but this time I'm going to put my number 24. We've got the integral from pi over 2 to 2 pi over 3. And this one is of negative cosecant squared. x dx. And again, we don't have to worry about u substitution because cosecant squared, that's something that you should be able to integrate. But again, it's got this negative out here. So first thing I want to do is to take that negative to the outside. Let's just skip right ahead, skip a step here, and switch these bounds so we don't have to worry about the negative anymore. So upper bound now is going to be pi over 2, and the lower bound is going to be 2 pi over 3. And since we switched the bounds, that's automatically going to change the sign. So now it's positive cosecant squared x dx. And again, that's kind of a fundamental integral that you have to have memorized. And the integral of that is going to be negative cotangent. So we're going to evaluate negative cotangent x from our upper bound of pi over 2 to 2 pi over 3. Now, even at this point, since we have this negative here, we could change the bounds. So that is going to be the same. Oops. That is going to be the same as cotangent x, and just change these bounds. So now it's 2 pi over 3 at the top and pi over 2 down here. And cotangent, remember, is the reciprocal of tangent. Cotangent is the reciprocal of tangent. Cotangent is, well, tangent is opposite over adjacent. So this one's going to be adjacent over opposite. Adjacent over opposite. And again, we're going to use our special triangle of pi over 6 and pi over 3. And this is 2, and this is 1, and this is square root of 3. And so cotangent of 2 pi over 3, where would that be on the inner circle? 2 pi over 3 means we're almost at pi, but not quite. So there's 2 pi over 3. Tangent is negative because tangent is the slope of these lines here. So the slope of this line is negative. So tangent is going to be negative of 2 pi over 3. So cotangent is going to be negative of 2 pi over 3. And to figure out what it is, 2 pi over 3, well, that leaves an angle here of pi over 3. So there's our reference angle. And cotangent, again, is adjacent. So it's going to be 1 over opposite, 1 over square root of 3. And cotangent, as well as tangent, are negative in this quadrant. So it's going to be negative. And then we're going to subtract, well, we got to subtract cotangent of pi over 2. Where is pi over 2? Pi over 2 would be right here. And usually tangent would be undefined, but cotangent is going to be 0 there. So cotangent of pi over 2 is 0. So we can simplify this, and we would have negative 1 over the square root of 3. Now, sometimes you don't want to leave it as square roots on the bottom, so you may multiply the top and the bottom by another square root of 3 to rationalize that. And that's going to give us negative square root of 3 over 3 for our final answer. So that is how you do 23 and 24. And I'll be posting another video on how to do some more definite integrals from Khan Academy, but hope you liked it.